Okay, in this video we're going to continue discussing graphs of polynomials. We're going to step it up a notch. Now, don't be too alarmed when we start this game because it does say that this is about polynomial graphs for a pre-calculus class. It's the same material that we've covered in Algebra 2. So let's see how we do with these these 7 questions. If we have a picture of a graph here, does the graph have an even degree or an odd degree? Well, if the tails are pointing in opposite directions, then that tells me that this has an odd degree. If they were pointing in the same direction, we'd have an even degree. So we know that this can be determined. This graph has to have an odd degree, which is the blue diamond, so I'll make that selection. Okay, so there shouldn't be any surprises there for that one. Let's see what this next one asks. Now here we need to answer how many real roots does the function have. Well, if you recall, another name for roots are solutions, x-intercepts, zeros, etc. So I don't know what the total degree of this function is, but I have a pretty good idea. What I do know is that it crosses the x-axis 5 different times, so there must be at least 5, or there must be exactly 5 real roots. The orange circle should do it. And there we go. All right, so that one was good. Okay, well, let's talk about factored forms of a graph. Well, here we've got a graph that's touching the x-axis pretty clearly at +1, +2, and +3. So if you recall from last quarter, the zeros that exist at x equals 1, at x equals 2, and at x equals 3 would look like this: x minus 1, x minus 2, and x minus 3. If you recall, we have to switch the signs of these solutions, and the reason for that is because the answer to a question like this, when does x minus 1 equal 0? Well, that happens when x is equal to 1. So because the solution to this equation is at the number 1, then we write the factor x minus 1. And so at first glance, you might think that this is a pretty good answer, and that is a choice here, if I'm not mistaken. Red triangle looks good, but I will caution you, this little turn right here on the graph, you'll notice that the graph doesn't actually go through the x-axis. It just bumps into the x-axis and turns away. It's what we called multiplicity. And so this little section right here, if I were able to zoom in right here, this would kind of look like a parabola that has a power of x squared. So that factor at that position has to be squared. So while I like x minus 1, x minus 2, and x minus 3, I think the answer that we're after is x minus 1 squared because of this multiplicity, x minus 2, and x minus 3. So I'm going to go with blue diamond as this answer. And that looks like a good one here. Let's see another. Imaginary number solutions or complex number solutions. Well, in this particular function, it's got lots of curves and turns to it, but that doesn't indicate solutions. Solutions exist at the x-axis. So according to this picture, I have 1 real, 2 real, 3 real solutions. And that's all well and good. I know that I have 3 real number solutions, but since the equation is provided to us, x to the 5th power is our degree, then the degree of 5 tells me that there's our total of 5 solutions. Well, if there are 5 solutions in total, 3 of which are real numbers, then if I subtract those 2, then that tells me that 2 of our solutions have to be imaginary. So I'm going to go with green square for this one. And there we go. Good answer. Okay, answer streak is now at 4, which is good, and I'm earning over 1,000 points. For this game, if you're playing this in class, I'd like to see if you can get to 7,000 points total, including your streaks and bonuses. Okay, which of the polynomials could be a graph to this? Well, I know that this is a negative leading coefficient because of the downward right arrow, and I know that this is an odd degree because these are two tails are pointing in the opposite direction. So with a negative leading coefficient and an odd degree, it looks like the only choice we have is this orange circle, so I'm going to make that one. That was a quick question. It started to make me a little bit nervous with the time running out there, but that was the right one to make. If you're well aware of the process to each of these questions, then the time shouldn't be a factor for you. So how many complex solutions or imaginary number solutions does this have? Now, we've only got an equation provided. We don't have a graph, so I'm going to go ahead and turn on Desmos here. Let me see if I can find my link to get to Desmos. Sorry about that, it was hidden off screen. So we are running a little bit out of time here. I don't know if I'll be able to make this in the 2-minute time. I should have had my website up and running. So I need to graph this equation, negative 2x to the 4th minus 6x cubed. So I'll start here. Negative 2x to the 4th minus 6x to the 3rd plus 3x squared minus 8x plus 1 plus 3x squared minus, I already forgot that, 8x plus 1. All right, so there's the graph. I'm going to kind of pinch and zoom out a little bit so I have a better view of this. Now, again, with this graph being, or with the equation being a 4th degree, I know that there are 4 solutions, but it looks like the graph only touches the x-axis at 2 places. Sorry, that first one was not an x-intercept. So there are only 2 x-intercepts, so 2 real number solutions. Therefore, imaginary solutions have to be 2 as well. There are 2 real, 2 imaginary for a total of 4 solutions. So I'm going to go with blue diamond on this one. And there we go. So that was a bit stressful. We had 2 minutes to answer that, and I used almost the full 2 minutes. But if you were prepared and had your equipment in front of you, you should definitely be able to answer that a little bit quicker than I did. All right, let's see about this last question. Which equation has the following behavior? Now, this is again that notation that we're not real confident with. I know a lot of us were still struggling with this, but you'll notice that the instructions are telling us as x approaches infinity. So this is talking about the right tail. The function has to go to negative infinity. So x approaches infinity means the right side tail. This one means the function itself is approaching negative infinity, so it's pointing down. So which of these functions would have a right side tail pointing down? Well, the only way we can get a right tail pointing down is if we have a negative leading coefficient. So it looks like blue diamond and green square are 2 choices that might work. Now, the left side tail, as x approaches negative infinity, is also approaching negative infinity. So that means it's pointing down as well. So while this bit of information here on the left is telling us that the right side tail is pointing down, this bit of information on the right is telling us that the left side tail is also pointing down. So to get 2 tails pointing in the same direction, we need an even degree polynomial. Negative x to the 4th power ought to fit the bill. Right side down, left side down, they're both pointing together. Negative leading coefficient, even degree. I like green square in this case. Now, of course, you could have graphed all 4 of these examples. There's nothing wrong with that. It probably would have taken you a little bit more time, if you know your vocabulary, that is. But if you're completely lost and you're trying to make an educated guess, then I think that would be a perfectly fine approach. You have a graphing calculator in front of you, go ahead and use it and graph all 4 and make sure that you can find an equation that fits those descriptions. Well, my goal was to get to 7,000 points. I didn't quite make it because, well, I just took too much time. Hopefully with your understanding of the content, you would have done better. And if you do get a chance to play this in class, go ahead and challenge yourself. Try to make it to 7,000 points in this particular example. Thanks for watching. Good luck.